Okay, today we're going to learn about law of cosines. We have learned extensively about law of sines. Those two were kind of like straightforward cases. This, of course, is the ambiguous case. Today we're going to learn how to solve these two cases using law of sines, and it's impossible, just given the angles, to solve a triangle. We just don't have enough information. But before we give you the law of cosines, I'm going to kind of derive it. So you don't have to write this down in your notes, but I want you to kind of pay attention. For this, we're going to call this length x. And this whole side BC is a, so that by default means this side would be a minus x. Let's just do the Pythagorean theorem here. So I'm going to start with this triangle, right triangle on the left. So it'll be c squared equals a minus x quantity squared. Plus, we're going to call this the height, so plus h squared. And then this right triangle on the right, I'm going to call that, so I'm going to say b squared equals x squared plus h squared. So I'm going to kind of do some foiling here. So c squared equals, if I kind of FOIL that out, I get a squared minus 2ax plus x squared. To substitute here, I'm going to solve this one so I'm going to move that over. I'm going to subtract x squared from both sides, so I get h squared equals b squared minus x squared. So I'm going to substitute that in. Instead of h squared here, I'm going to plug in this. So plus b squared minus x squared. Well, the nice thing is the x squared minus x squared goes away. Okay, we're getting somewhere here. I'm going to reorganize this just a little bit. C squared equals a squared plus b squared minus 2ax. We're getting really close to the formula. So I also want to kind of look over here. We're going to actually use cosine here. So if you look at angle C here, so the cosine of angle C is just x over b, right? So if I solve that one for x and multiply by b, you get x equals b cosine c. So instead of x right here, I'm going to plug in b cosine c. So let's see what happens. So c squared equals a squared plus b squared minus 2ab times cosine c. Okay, so that is actually the law of cosines. That's where it comes from. One way of deriving it is a Pythagorean identity. Let's talk about it. Okay, so in the formula, so that definitely write this down in your notes now. In the formula, you definitely want to understand that, like, this triangle is DEF. It doesn't have A, B, or C. So this formula is flexible. The key thing you need to realize is the angle goes in this slot. You notice that's the only capital letter. All the other sides are lowercase. And the key thing also is to understand that this side, lowercase c, is opposite of this angle right here. So in this problem, obviously the d is the angle, which means lowercase d is my c at the start of this problem, if that kind of makes sense, right? So use the law of cosines. So we're going to set up the law of cosines using these variables and these numbers. So we're going to plug in, understanding that c is really, a and b are interchangeable. You could do 24 or 18 for a and b or switch them up. But the key thing is the angle has to go in that slot. It has to go in the c slot in that case. So let's plug into the formula. So we get so d squared, that's what we're trying to find, I think, here, equals a squared. We're just going to call it 24 squared plus 18 squared minus 2 times 24 times 18 times cosine of this angle 57, so cosine of 57. Now, the nice thing about the SAS case, which is what this is, once you set it up, I mean, my goodness, you just type in your calculator. What could be easier than this, right? So set it up, so we just type in, 24 squared plus 18 squared. Make sure you're in degree mode, of course I am. I'm looking at the top corner of my screen, times 24 times 18 times cosine of 57. And I want a decimal, so I'm going to put a decimal in there. There we go. So d squared equals 429 point. And we could get more decimals if we want. I come mousing up and pressing enter. So 429.4319. 4319. Well, that seems awfully. The other sides are 24 and 18, and this is 429. That doesn't make sense. Oh, if you're paying attention, the big thing you do have to pay attention to this is this is d squared. Oh, okay. So we have to take the square root of both sides. In this context, you don't need to use plus or minus. The reason is because we're talking about side lengths, and so we don't really have, we're not really dealing with negative side lengths in Algebra 2. So we get d equals, and so again, we just typed that in our calculator, but you do have to pay attention because that'd be an easy mistake to make. So square root of, I just like to grab that term up there, so I mouse up there, press enter, and you get, okay, so this looks better. 20, that seems more reasonable, 20.7227. So it's pretty neat. That's not a right triangle, and we still were able to find the third side relatively painlessly. So we first used the law of cosine. So step 2, now that we know that that is 20.7227, now we can use good old-fashioned law of sines. We could use law of cosines again, but almost to a fault, every student goes, well, law of sines just seems a little easier to deal with. So we're going to set up a law of sines. Let's solve for maybe angle F next. So this will be sine of 57 over 20.7227 equals sine of F over 24. Go ahead and cross multiply and solve. I'm going to solve that for sine of F. So sine of F is going to equal 24 times sine of 57 all over 20.7227. And then you're going to take the inverse sine of that side. So F is going to equal the inverse sine of whatever that number is, basically. So let's type that in, see what we get. So we go, okay, 24 times sine 57 over 20.7227. That's that. And now we're going to take the inverse sine of that. So inverse sine is the trick here. Inverse sine of that number, and you get that. So inverse sine of 0.9713, and F is equal to 76.2414. So the third step we're going to do, so that's nice, we got angle F, is use the angle sum theorem. You don't have to know the name, but just that if you know two angles of a triangle, can you figure out the third? Well, sure you can. So we're just going to add that to I think the other angle is 57. Take 180 and subtract that total. Done this before. And so we get for angle, I guess that would be angle E, is equal to, and this is technically degrees, 46.7586 degrees. And we have solved that triangle. We found all the angles and all the sides. So actually, you know, these three steps, that's pretty much how law of cosines. You're going to use law of cosines, then you use law of sines, and then angle sum theorem given that particular case. That's probably the easier case of the two, I would say. The tougher case is the side. So that's what we're going to do next. Whoops. So let's try that one. So again, we're in a situation where we don't know which angle is C. So In this case, we have to decide which angle, and I would always choose the largest angle. If you're given a choice, like you could choose solve for any angle here, I would definitely choose the largest, which is opposite the largest side. So 15 is the largest side, so we're going to try to find angle E. So in this case, E is going to be my C here. Lowercase e is my side opposite the angle we're looking for. And then A and B are the other two sides. It doesn't matter the order of those in the formula here. So let's set it up. And that's not the hard part. I'll show you what the hard part is here. So we do actually know what little e squared is here. So this is going to be 15 squared equals 7 squared plus 9 squared minus 2 times 7 times 9 times cosine of C, or which is in this case is angle E. Okay, so now we have to solve for angle E. Like that's where we're solving for. So I have to kind of move some of these things over to the other side. I'm going to just kind of this time just kind of not multiply it out, but you certainly could multiply this out. The first step is to move the loose terms. So don't divide first. It's really going to cause a lot of problems here. So I'm going to subtract these two. So I'm going to subtract 7 squared and 9 squared over from both sides. And again, I'm going to keep it in this form just for a second, just so you can see what I actually did. So minus 7 squared minus 9 squared equals, that's nicely cancels out. So we get negative 2 times 7 times 9 times cosine of capital E, angle E. Okay, this is being multiplied now. So see, those terms were just being added, so we had to subtract them. This is being multiplied. So now I divide it. It's key that you subtract those first two terms first, and then you're going to divide by the negative, in this case, negative 2 times 7 times 9. So divide by negative 2 times 7 times 9. And again, you could have like simplified some of this, but I wanted you to see what happens. So I'm going to move the cosine of E to the other side. So cosine of E equals, and I'm going to type this into my calculator. So I'm just going to get the decimal there. So let's try that. So 15 squared minus 7 squared minus 9 squared all over negative 2 times 7 times 9. We get that fraction, which is negative 0.7540, essentially, when you round it. Okay, so now we're going to take the inverse cosine of that to solve. Inverse cosine of that number, and you get E is equal to 138.935. Let's just kind of check that. 0.9353. To get another decimal, use mouse up and press enter. Okay, so now we now have angle E, and now we can do so kind of like we did before. So the first step, law of cosines. Guess what the second step is? Law of sines. So let's go ahead and solve for angle F now. So we have sine of angle E, which is 138.9353 over lowercase e, which is 15, equals sine of F over 7, it's opposite side. We're solving for sine of F. So I'm just going to go to the next step just to save skipping a step. So this would be 7 times sine 138.9353 over 15. And this inverse sine of that, so we're going to do that. So we get inverse sine the fraction 7 times, see if I can grab that, 138.953 divided by 15. Okay, sorry about that. Let me do the correct problem. So it was sine times sine of that number. There we go. That makes sense. So F is, well, pretty small angle. It's 17.8519. And the third step, we used angle sum theorem. Again, you're just adding up the angles and subtracting from 180. So we're going to add up that with the 138.935. Do 180 minus that number, and we get angle D. So that's our F. Angle D is 23.212128. We got it. So the cadence is actually pretty much the same. And again, the key thing there you've got to remember is first things first. So once you set up the equation, these two you've got to subtract, and then these guys you have to divide out. And in that order, you have to subtract those two terms first, and then you have to divide, including the negative. Divide those out, and then you'll take the inverse cosine of both sides. So if you can remember that, this law of cosines actually is much more straightforward than, say, law of sines ambiguous case, because there's only one answer there. That's the lesson. Here's just a PSAT. If you want to try it real quick. So following which the percent decrease in consumption of wood power from 2000 to 2010. So it went from, looks like 2.25 to maybe 2. So it went down 0.25. We're comparing it to the original of 2.25. So if you get to calculate out what is, well, you probably know, 0.25 divided by 2.25, but at least that's 1/9, right? So which is 0.111, so 11%, and you get it. Okay, so have fun doing your homework.